Okay, so we're going to review transformations in one day. You should have done a ton of transformations last year. Here I've got the mature mathematical vocabulary to describe things where you might use the word flip, it flips. But mature vocab, we might say it has a reflection in the x-axis, okay? So that's what's listed in this first column is a vertical reflection. In quotes is what you would say, reflect in the x-axis. The function notation, you might see function notation somewhere. This would be whatever function it is. So somebody give me a function. Your favorite function, what is it? Parent function. Give me your favorite parent function. Oh, we can do 3x plus 2. Was it 3? Okay, 3x plus 2 is his favorite function. To make a vertical reflection, a reflect in the x-axis, we put a negative sign out front of that entire function. So now where my students make mistakes is they only put a negative with the 3. But if I'm going to take Matthew's, it was your function, right? Matthew's favorite function and reflect the entire function, this would be negative 3x minus 2. Like that negative is going to go to the entire function. Okay? So that would be a place that some students make mistakes. So make sure we know the negative goes to the whole function. What happens to the function? We multiply the entire function by negative 1. I don't like how it's like over here and then over here. Negative 1, okay. And then a special note, make sure that we put brackets around the function before we put that minus sign in front so that we don't forget to distribute if needed. We don't always need to, but sometimes we will. So that's reflecting it in the x-axis. This next part I can't really like show you on the video, but I'm gonna have you guys do it with me. This little kinesthetic thing. Can you guys like give me an x-axis? And then put something above your x-axis. All right, so we're gonna reflect the hand in the x-axis. You see, reflecting it. Okay, that is going vertical. Okay, that is going vertical. Even though I'm saying the word x-axis, it's reflecting in a vertical direction. People mix those up. They think, oh, it's a vertical reflection, we say in the y-axis. But no, give me a y-axis and give me something on one side of the y-axis. Which direction do we reflect if it's in that y-axis? Why am I the only one looking like this? Horizontal, right. So that's another mistake some people make. All right, a vertical stretch or a shrink. So if we have either of those, a vertical stretch or we say a vertical shrink by a factor of, and then there will be a number there. I am not even scrolling it over for a second. Do you guys know what makes it a stretch versus a shrink? Does anybody remember what makes it a stretch, Alex? Close. It's above something, but it's not 0. Above 1, because 1 would keep it the same. So if we're above 1, it's going to make it bigger. If we're between 0 and 1, it's going to shrink it. Why am I not talking about negative numbers? Alex? Because that's a completely different transformation that reflects it. So we separate those. All right, to write it with function notation, we would have a number outside of the function. Noah, what's your favorite function? X squared. Okay. It's very original. And give me a number to either stretch or shrink it by. 2. Is that going to be a stretch or a shrink? Okay, that is a stretch. So we're going to stretch x squared by a factor of 2. We can simplify that and write 2x squared. Yeah? So what you would do, you multiply the entire function by whatever that value is. It will stretch. We just said this. If it's greater than 1 or if it's between 0 and 1, it will shrink. And then you put it outside of a bracket because sometimes we need to distribute. We didn't need to on that one. Okay. Horizontal reflection we say a reflect in the y-axis. Reflect in the y-axis. And we just demonstrated our horizontal reflection with our hand and arm. Function notation, you will see this negative sign inside of the function. This is inside of the function. I don't want to write it in pink. Just wrote pink. One more. We'll say this is inside of the function. Sydney, give me a function.
X cubed.
Okay. X cubed. You guys are so original. So to write x cubed and to put, oops, that was a squared. To put a negative x inside of the function, it's going to be like a negative x, and then that negative also gets cubed. So if the negative was not inside of the cubed, that would be a vertical reflection. So it's got to be inside of those parentheses or absolute value bars or square root symbol. It'd have to be underneath. Can we just not think of any fun functions? Is that what's going on? Too much stress? My mind is blank. Yes, Ria.
If there was something else inside of the parentheses,
Do you want to give me a more creative one so we could do more? Okay, so if the function, she likes negative x minus 4 like this. Okay, so if I were to make this a reflection in the y-axis, let me zoom in. Sorry, I wrote it really small. If I were to take this and reflect in the y-axis, I would keep that negative sign. Then I would make my x into negative x. And then I would have a minus 4 out there as well. So what we're doing, I probably have it written over here. Yeah. So what we're doing, it's what I have written in the next column, is we replace our x with parenthesis negative x. So this would end up being positive x minus 4. Or let's say I had, I'm going to make something even crazier up. Square root of 3x minus 9. I don't know. Okay. If I were to reflect that in the y-axis, I would take my x and change it into negative x, and everything else would still be there. And then I would simplify it. So then I would get square root of negative 3x minus 9. So that negative didn't affect the minus 9. It only affected the 3. Did I answer your question? Okay. I was hoping people would give me more creative ones so I can show you that stuff. All right, so that's replace x with square root of, or not square root, parenthesis negative x. And then we want to use these parentheses where we're substituting so we don't make silly mistakes. Okay, next is a horizontal stretch or shrink. A horizontal stretch or shrink. We would say horizontal stretch by factor of the reciprocal of b. 1 over b is the reciprocal. Or a horizontal shrink by a factor of, and then you would say the reciprocal of whatever b is. If I say a horizontal stretch by a factor of, if I were going to give a number that would make sense in this sentence, horizontal stretch by a factor of, could somebody tell me a number? DJ? 10? Somebody else said 10, you copied? Okay. A horizontal stretch by a factor of 10 makes sense because stretch and 10 go together. I would not say a horizontal shrink by a factor of 10. Okay? But I could say a horizontal shrink by a factor of 1/10? Sure. Okay. So this would be where we have a number inside of the function. We're inserting a number inside of the function with the x. So, Christina, can you give me your favorite function?
1/2 x squared plus 5.
Okay, so 1/2 x squared plus 5. And give me a b value.
2.
Okay, so that would be, actually, if I put 2 in there, that means I'm going to replace, like if I do f of 2x, I'm going to replace x with 2x in her function. So I'll have 1/2 parenthesis 2x close parenthesis squared plus 5. So I replaced x with 2x. The 1/2 is still in front, the squared is still in the back. I can simplify this. And if I can, I will simplify it. Evan, do you know how to simplify it?
Oh, you mean like?
What would I do?
Oh, you would do 2x times 2x.
Which is, so I'd have half of 4x squared plus 5. Then what would I do? Then what can I do? I can still simplify something. It's okay to get rid of the parentheses, is what I'm saying. Because I messed up. Because I wasn't paying close enough. I meant to keep the parentheses, but I meant to put the squared on the inside. Sorry. Sometimes I mess up. So now what do I do? Times what, hon? Oh, did you do it in your head and tell me the answer? Maybe you don't. He doesn't know what he's doing. Can somebody help him? Charlie? Multiply what by 1/2? And you get what? Okay. So that would be this equation and this equation are equivalent. These are equal. One of them shows that I'm making a transformation. The other one, you just can't see the transformation, but it's simplified. We always simplify equations. I don't want to try to graph that first one. I'm going to have an easier time graphing the second one. Okay, so we do want to simplify them where we can. Did I lose anybody on this? Okay. And then the directions, you're going to replace x with bx. Oh, I didn't answer the other thing I was thinking in my head. Is this a stretch or a shrink? So when I write the words out, a horizontal stretch or shrink by a factor of 1/b. So if b was 2, what's my factor going to be? So is that a stretch or a shrink? I did not hear that answer. That is a shrink. So the number that goes in the equation is opposite of what actually is happening on the graph. What's the next one? Horizontal translation, left or right. We'll do both of them at the same time. Translate to the left, h units. Translate to the right, h units. We'll look at both of those at the same time. We can see both of them have replaced x with, and a parenthesis, either x plus h or x minus h. The thing that you have to remember that hopefully you remember from last year is when it goes to the left, why is this not working? Oh, because I did the wrong thing. When it goes to the left, it's adding. When it goes to the right, it's subtracting. In fact, everything up here that is a horizontal is opposite operation. Everything up here that's horizontal is an opposite operation. It's like, doesn't make sense. Opposite of what makes sense. So when we did the horizontal stretch or shrink, if we have a 2 in there, we're actually dividing by 2 instead of multiplying by 2. But I don't divide by 2, I multiply by 1/2, same thing, right? So instead of adding a number, we actually go to the left, or vice versa. If I'm going to the right, instead of adding it, I go subtract. So it's opposite. Everything horizontal is opposite. Everything. Like instead of multiplying by a -1 for a horizontal reflection, instead of multiplying by a -1, you know what I really did? What's the opposite of multiplying by -1? Dividing by -1. That's what I really did. No? Nothing. Matthew? They're the same, right? Oh, okay. I'm just trying to show you the rule works for all of them, even if it's that one. Okay. So I need a function. Who wants to give me a function? Catherine, you give me a function?
Okay. X squared minus 4.
X squared minus 4. Oops, that's not a pen. There's Catherine's function. And then, Catherine, can you tell me if I should do f of x plus a number and give me that number, or x minus the number? Like, you tell me what I'm doing. I'm doing f of what? I'm going to do x. I'm either going to do plus or minus, your choice, and then a number, your choice.
Plus 2.
Plus 2. Okay, that's fine. So if we need to do f of x plus 2, in the equation, that means to replace x with parenthesis x plus 2. So my new equation is now going to look like parenthesis x plus 2 close parenthesis squared minus 4. All right. This means to translate which direction? To the left 2 units. I could multiply this out, but when we actually start graphing these, it is better to be in this form for transformations with quadratics. When it was lines, the one that I multiplied up earlier, I think was a line. Oh, no, it was a quadratic also. But with this, it's better that we don't have that middle x term to use it. So I would leave it like that. All right, then finally we have vertical translation, either up or down. The k units. Up k, down k. You can see that these match exactly with the what I'm saying. If it's up, it's plus. If it's down, it's minus. You'll see that it goes outside of the entire function. Pierce, you want to give me a function? Make it a hard one. No, don't make it a hard one. Just give me a function. Minus 7. Very good one. Okay. So if we have x cubed minus 7, I'm not done with you, Pierce. Then we're going to do f of x. And I want you to tell me what number I should either add or subtract on the outside of it. Oh, okay. Add 2. Very, very, very unique. Okay. I'm just joking. Okay, so if we add 2, that is going to be a translate which direction? Up 2 units. That's what the graph would do. So we take x cubed minus 7, we translate up. But if I'm going to write the equation for it, then I'm going to put brackets around the entire thing and write plus 2. I do feel like this should be simplified. Okay. So then I'll just simplify it and we'll have x cubed plus 5. So if it's simplified, I can tell right here that this x cubed is going to hit the y-axis at 5. Like I can graph it really fast. Where if it's not simplified, I would have to like say, well, it hits at -7, but then it goes up. Oh, I can't do math is what you're saying? My bad. I told you guys, I make mistakes. I'm not a robot. I'm not a very good robot. Anyway, this would be at -5. And if I didn't combine it, then I would have to be like, well, go down 7 and then go back up 2, which is more work. So, all right, your assignment is going to be words. Like, I don't know if I have it open here. Is this is not it. I don't know where it is. Yeah, it is this. Okay, so your assignment, when you click on it, it is an equation, a function, and then words, and you just have to write the new function. You'll be typing it into Canvas. You don't even have to put the f of x. I've already typed that part in for you. You just have to put the new function. If you're getting it wrong, ask questions. There's only 15 of them. That's it. And none of them should be super hard. Yeah, David. Yeah. You potentially could have it done I don't know. What time are we out of here? 10? Potentially you could have it done before you leave today. Okay.